All right, so we'd like to do 12.5, number 43 and 44, which say we should use f and g as given to re-express these guys. All right, so if I want to express x squared plus root x plus 1 as some root x's and some x squared plus 1s, what do you see there?
You need to stick them together with addition, maybe?
Yeah, I got to stick them together somehow, right? And there's only so many operations I know. I might notice that, like, this piece looks like a g, right? And then if I take that out of there, I'd be left with the rest, right? X squared plus 1. And that's an f, right? So maybe I would think to myself, okay, if I put the root x first, and then added the x squared plus 1, is this any different? What have I used here?
Order of operations.
Yeah, not even really. I just used that addition doesn't care about order or grouping, right? These are commutativity of addition and associativity of addition. The associativity is a grouping thing. The commutativity is an order thing. So here, I rearrange the order. That's commutativity or order. And then I group these guys. That's associativity. This is really the same thing, right? And now I might say, oh, and now this piece is, that's G. And the other piece is F. Okay, so I found out that H is G plus F, or actually maybe if I was doing things in exactly the way your book does, I would probably rewrite this as, your book has an obsession with putting things in alphabetical order.
Okay.
So I would probably rewrite this according to your book's rule as f of x plus g of x is h of x. Right? It's because they, for some reason, seem to care about alphabetical order.
Well,
But whatever. I'm okay with either way.
when you're looking at the book, you can just look at the alphabetical order, put them there, and then add in the symbols between them to make it work.
Okay. How about the other one? So I want to express x plus 1 in terms of x squared plus 1 and root x. And they told me this weird thing, right? About x's having to be positive. Thought?
Yeah, because if x
That's
is
assuming
less,
that x.
it'll
So,
It's probably because if x is less than 0, something's broken, right?
so it's f of g of x.
F of g of x.
As if you know that x is
Yeah.
greater than 0.
So this is really me thinking, okay, I'm adding 1 on the outside, right? That probably means I'm doing f after g. And then I might think to myself, okay, maybe this is f composed with g of x, right? So if I wrote down what I mean by that, that's
X squared.
x
The root of x.
root of x, right? So I got to do g first. That's rooting. Then I should take the result, root x, square it, and add 1. And now this actually is x, right?
Well, it's x if x is.
But only if x is positive or 0, right? You guys see that? Ah, that's where this silly restriction came from, right? Because they had to write down, we're going to restrict the domain to x is positive or 0, because otherwise these two aren't actually the same thing. You guys see that? So I can drop my wondering, and h is f composed with g. Does that make sense?
yeah.
I feel like that one was nicer than 42.
Yeah, I don't know, maybe.
Just a little bit.
personally, I feel like 43 was easier, but everybody's mind works in kind of subtly different ways. So some of you certainly will see the other way easier. The domain restriction was probably the big clue there. Anything else?